Oh, example 1. Consider the previous problem in which the stress element at H was determined. That was our leading example 2. Okay, there we determined the normal stress and the shear stress at point H. So as indicated here in this drawing. Then we have 2 steps. Step A, draw a stress element for rotated element at H if theta equals 45 degrees from x-axis. Then we determine the principal normal stresses and maximum shear stress at H. Okay, we already derived these equations. We have 3 equations so that you can use for step A, and we have other equations to determine the values of principal normal stresses and maximum shear stresses, and we have equations to find their positions, to find out the theta p and theta s, right? So we just need to calculate them step by step. Okay, for the step A, we first of all list the numbers we already know. The sigma x equals 20.2 MPa. Sigma y equals 0. Okay, tau xy 62.65 MPa, and theta equals 45 degrees. Then just based on the 3 big equations, we can calculate theta n. Why theta n will be sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 cosine 2 theta plus tau xy sine 2 theta, and 2 theta equals 90 degrees, right? So cosine 2 theta will be 0, sine 2 theta will be 1. And here you will get 20.2 plus 0 over 2 plus 0 plus 62.65 times 1. So here you will get 72.75 MPa. Okay. If you turn this positive sign to negative, you can calculate the sigma t, right? Then we can calculate the tau nt. Right, the equation said negative sigma x minus sigma y over 2 sine 2 theta plus tau xy cosine 2 theta. Again, here you get 1, here you get 0. So here you get a negative 20.2 over 2. I get negative 10.1 MPa. Okay, and to calculate sigma t, as we mentioned, you can just turn the positive signs in the first equation into negative signs. Then you will get this result, but that calculation is long. So here, to be simple, we can use the first invariant, the first constant I1. So if you recall, our I1 equals sigma x plus sigma y equals sigma n plus sigma t. Okay, this is a equation and a feature of them that they can use to simplify the calculation. So using this equation, you can see that the sigma t equals sigma x plus sigma y minus sigma n. Okay, that is just 20.2 minus 72.75. You get negative 52.55 MPa. So here we get this 3 result. After rotation, you get sigma n, you get tau nt, sigma t. Okay. Meaning that from the original stress element, after rotation by angle of 45 degree, right? This is the x-axis. From x rotated by 45 degrees Celsius, see what can we get? Okay, you get such a element. Where you have tau nt equals negative 10.1. Right, you have sigma n equals 72.75. You also have a sigma t equals negative 52.55. It's actually compression. Okay, the negative sign indicates that it's a compressive stress, normal stress. Okay, so you can see that after rotation we get a two-dimensional stress element. Although in the beginning your sigma y equals 0, so after rotation your sigma t is not 0. Okay, you get normal stresses along the two perpendicular directions. Then in step B, we'll determine the principal normal stresses and the maximum shear stresses, and we'll also examine their locations. Okay. So to find out the principal normal stresses, we have two equations, actually one, just plus or minus. Right? The sigma p1 equals sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 square plus tau xy square. Okay, here you have just 20.2 over 2 plus 20.2 over 2 square plus 62.65 square. And here you will get 10.1 plus 63.5. That is 73.6 MPa. Okay, so this is the first principal stress. And the second one, sigma P2, will be just you turn this negative sign into positive, this positive sign into minus. Right? So as a result, we will get 10.1 minus 63.5. You get negative 53.4 MPa. Okay, those are the two principal normal stresses. To find out the location, okay, we can do we can use the other equation that's tangent 2 times theta p equals tau xy over sigma x minus sigma y over 2. So here you will get actually 62.65 over 10.1. Okay, from here you can easily determine that the just use inverse tangent, right? The theta p can be calculated as 40.4 degree. Meaning that if you start from this original shear stress, shear element, the original stress element, you just rotate it, by theta p equals 40.4 degree. Then you will be able to find theta p1. Right, this is the maximum possible normal stress at this point. Okay, this is the maximum normal stress at this point. That is 73.6. Okay, of course you can find the other principal stress on a perpendicular direction. See here. Right, this is a negative value. Right, negative will be like this. Okay, this sigma p2 equals negative 63.4. Okay. Then let's find the maximum shear. Okay. We have another equation, that is the tau max equals the difference between the two principal stresses over 2. Okay, so that is 73.6 minus negative 53.4 over 2. So you get 63.5 MPa. This is the maximum shear stress. So at this point where your normal stresses, these two normal stresses will be the same, right? Their magnitude will be average equals half of sigma x plus sigma y over 2, right? That is 10.1. Okay, so where can we find it? Where can we find this maximum shear stress? Right, that is the theta s equals theta p minus 45 degree or plus 55 degree. Right? This, if you use minus 45 degree, you will get negative 4.6 degree. If you use plus, you will get 85.4 degree. So what does this mean? Meaning that if you start from the original stress element, where you have tau xy and you have sigma x, right? This is the original stress element. Starting from it, if you want to find the maximum shear stress, you will just need to rotate it by negative 4.6 degree. Just from the x-axis, rotated by negative 4.6 degree, means that you can rotate it here. Okay, here we say this is a negative 4.6 degree. So at this plane, you will be able to find the maximum tau max equals 63.5. or you can find it by a rotation of 85.4 degree. This can be achieved from here. Right, this is 85.4 degree. Right, so on this plane, you can also find tau max equals 63.5. Of course, at these locations, the normal stresses will be sigma average, or here, sigma average. Okay, those are both 10.1 MPa.